Hey everyone, this is the Math Nexus, and today we are going to start with exercise 3.5 of addition mathematics. And before I start, I would like to, I don't think this should be a new thing to you. It should be a kind of a revision thing. So the thing is, before we start, I would like to introduce you with conjugate searches. And the thing is, it's no new thing. We have been going through this throughout the chapter. Before this exercise in 3.2, 3.3, we have seen conjugate certs. And what conjugate certs basically are, they are basically the exact opposite of, for example, we have A plus B. So A minus B is the conjugate of that A plus B here. Okay. Similarly, A plus 6, for example, I'm just giving an example, 6 under root C. The conjugate of this would be A minus 6 under root C. So you see the difference between a positive and a negative makes the surds a conjugate surds. So basically, a difference from positive to negative in the main equation, I would say, would make up a conjugate surds. Would make up a conjugate surd, yeah. And the thing is, um, whenever we have conjugate surds, we are going to get a rational number. And what is a rational number? It's a whole number. For example, 4, 6, 7, 8, 9, 10. That these are rational numbers. So whenever we use a conjugate surds, we get a rational number. So basically, for example, we have a plus b under root c multiplied by a minus b under root c. That would be equals to what? That would be equals to a rational number. Okay. So just remember that. And I mean, there's a proof to this. How is that proof coming here? So basically, we know a plus b multiplied by a minus b is equals to a squared minus b squared. That's a quadratic identity we have learned till now. Similarly, if we consider this a as a, so a is equals to a, and the b is equals to b under root c. Basically, these a and b, which we assign these values to, they are not the same things. We are comparing them with a quadratic identity. I could write them as something like, for example, for your easiness, I could write them as x minus y multiplied by x plus y would give us x squared minus y squared. That's a trigonometric identity. And then I could compare it here. So x is equals to a, we see it here, and y is equals to b under root c. And basically, we see that a plus b, x plus b here, and x minus b here. So when we have conjugate surds, we basically, what we do is use the quadratic identity, which I think I have pasted it down here. Let me just see if I have. Yeah, here it is. To it's a tip in a book, and I would just recommend this every time. I mean, the most quickest possible way is to solve these type of things, conjugate surds, is to use the quadratic identity x plus y, x minus y is equal to x squared minus y squared. So that would give us something like that. Okay, I'll explain you with examples, no worries. Um, so this is basically how it works. So basically, when we apply that x squared, so we would get a squared in terms, I'm talking about this thing. I'm talking about this thing. So we would get a squared minus b under root c whole squared. And that would simplify to what? A squared minus b squared multiplied by c. So whenever we have a conjugate sense, it's really easy for us to solve it because we can use quadratic identities up here. So using the example which they have given in the book, we have 4 plus 2 under root 3, and we have 4 minus 2 under root 3. So again, the thing is, the only difference between them is the positive and negative. Other than that, all the values are same. That means this is a conjugate set. So A and B values are same. That's basically how we identify a conjugate set. So again, A plus B multiplied by a minus b is equals to a squared minus b squared. Again, the thing is, your basic math, your mental math, your quadratic identities, all of them should be at the best level possible for you. I mean, if you're an ADMA student, you should know that you should give your best in this. I mean, if maths, if you're good in maths, I don't think you might always be good in ADMAS because they are completely different concepts. I mean, had maths is like the advanced thing, and I don't know why, but if you look at O level maths, what's the first question that comes up? I mean, just simple questions like what is 4 under root 3 whole squared? These type of question come in maths P1 and even sometimes in P2. So don't expect that. I mean, and maths is similar to maths. I mean, there's a lot of difference in that. So back to add math. So the thing is, you should sharpen your basic math skills for this. So a plus b, a minus b is equal to a squared minus b squared. So again, we just apply the same thing. 4 squared minus 2 under root 3 squared is equals to 16 minus 2 to the 4. 4 under root 3 squared is equals to. So this is equals to 16 minus 4 3 is 12. This is equals to 4. Okay, so that's it. I mean, that's basically how you use conjugate search and quadratic identities together to find your answer. Now, the thing is, when do we mostly use conjugate search? Basically, the thing is, the main idea of conjugate search is to get a rational number. Okay, and basically, what we do is normally in maths, and even in maths, by the way, what we do is, for example, if we have our answer 6 under root 3 divided by under root 7, okay, something like that, what we do is we rationalize the denominator. You might have heard that term, rationalize the denominator. And what that basically means is we remove the under root sign from the denominator. Now, obviously, we can't just remove it and write out 7 instead of under root 7. That would be practically wrong. Okay. So we change the upper value, 6 under root 3, so that this value could be something which would give us the right answer. So basically, what we do in terms of these type of things is, and I hope you know that already because we have been doing this in, I guess, 3.3 and 3.2, that we rationalize the denominator. And what we basically do is multiply this by under root 7 divided by under root 7. And basically, why do we divide it by under root 7 divided by under root 7? The thing is, if we see 6 under root 3 divided by under root 7 multiplied by 1, I mean, what would you expect from this? You would say the answer is the same. Okay, so we would say that this is the correct methodology. We can do that. No difference in the answer will be seen, and that's basically what we're doing. What's under root 7 divided by under root 7? It's equals to 1. So basically, we are multiplying it by 1, but in a value that would be helpful to us. Okay, so basically, we multiply the under root by each other. So that we would get 6 under root 3 multiplied by 7 divided by 7. Now what we have is a value below in the denominator, which is not a third value, and we have changed the upper value 3 21. We have changed the upper value so that it could help us find the answer easily. So basically, this is the type of rules you would call really rules. I mean, yeah, there's no back to it. I mean, if you are given an answer and it's having a denominator it's having a third in the denominator, you might get marks for it, but it's practically wrong. Okay, so whenever you get a third in a denominator, please do simplify it until and unless they have specified that in the question. Now that was simple. We got under root 7 multiplied by under root 7. Now basically, most students make the mistake. For example, we have something like 6 under root 3 divided by 5 plus under root 2. Okay. So basically, some students make the mistake. They multiply 5 plus under root 2 divided by 5 plus under root 2. So that's basically the same value, we may say. But the answer would be different. Why would be that happening? Because this is a plus b whole squared. 5 plus under root 2 multiplied by 5 plus under root 2. And before I proceed, let me just get this up here. Put like that. Oops. Is it? That's here we go. So basically, if in fact, so basically what happens right now is this becomes, sorry, not here, 6 under root 3 whole square multiplied by 5 plus under root 2 divided by, however, this won't be the right answer, because if we multiply 5 plus under root 2 multiplied by 5 plus under root 2, I would use the FOIL method right now. In fact, I would use the quadratic identity a plus b whole squared, because this is the same value. So a squared plus 2ab plus b squared. Wow. I found an answer for this one. I mean, in this method, even that is going correct. My bad for that. I'm not supposed to give you easy questions like these. Okay. Even in fact, the examiner won't give you an easy question like this. For example, we have got something like 5 under root what? 3. No, not 3, 6. Yeah, 6 is good. So plus 2. Okay. 5 under root 6 plus 2. Yeah, that's okay. Now, basically, if we multiply this by 5 under root 6 plus 2 divided by 5 under root 6 plus 2, again, the methodology would be simple. We would say multiplied by 1. However, if we would find 5 under root 6 plus 2 whole squared, we would get something different. And what would be that? We would get a squared 25 multiplied by 6 plus 2 multiplied by a 5 under root 6 multiplied by b plus b squared. Okay, the thing is, if you would solve that up now, you would get 25 multiplied by 6 is equals to 150 plus 5 to the 10, 10 to the 20, 20 under root 6 plus 4. Now the thing is, you have a problem right here. And what's the problem? Problem is you still have a surd here, 20 under root 6. So if we would write our answer, this would be 6 under root 3 multiplied by 5 under root 6 plus 2 divided by 154 plus 20 under root 6. And I've told you right now that it's not favorable that we get a surd in the denominator. Now what? I mean, we have used the same thing here, but we won't get the same answer. That's where conjugate surds come in. I mean, we have been discussing those things from the starting of this lecture, and that's where this actually comes in. That's why this build-up was all for. So basically, in these type of questions, we don't multiply by the same under root value, okay? We multiply it by something different. This would be wrong, okay? We multiply 6 under root 3 divided by 5 under root 6 plus 2 by the conjugate surd of the denominator. And what I mean by this, we don't multiply by 5 under root 6 plus 2, we multiply it by 5 under root 6 minus 2. And we divide it by 5 under root 6 minus 2. Now, basically, this is again equals to what? 1. So there's no difference in the answer. Okay, the answer would be the same. However, what would be the difference? We now have a conjugate surd. So basically, the upper part would be solved like multiplying, obviously, the same simple multiplication, 506 minus 2. And the lower part, however, would be a plus b, a minus b. So again, as we discussed in this one, a plus x plus yx minus y is equals to x squared minus y squared. So that's basically the beauty of conjugate surds. Now you can easily solve this. So 5 under root 6 whole squared plus 2 whole squared. Sorry, not plus, sorry, my bad. Minus 2 whole squared. And that would give us a value which is independent of a cert. I won't be solving this right now. I will be solving the rest of the questions in this exercise so that you may know. And I hope that's clear for you. That's the basic concept for conjugate search and everything. So I think that's about it for what you should know before starting this exercise. And let's proceed on to the questions. And before we start, again, a reminder, whenever we multiply some a plus b or some value, we multiply the conjugate surd of that value. However, if we multiply a single digit, a single under root, we multiply by the same under root value and divide by the same under root value. I hope that's clear. If your concepts are not clear, don't worry. We'll get through them in the questions. I'll try my best to explain in the best detail possible. So proceeding on to the questions. Before I proceed, let me just, clear the page, in fact. Okay. Now proceeding on to question number 1. Here we have it. So basically, again, if your concepts are clear throughout my introductory session, you will know what to do. So basically, let's start with 3.5 and that's it. So question number 1, part A, 1 upon under root 5. Again, this is really simple, really simple. We've discussed to remove this we have to rationalize the denominator. To rationalize, multiply and divide by what? Under root 5. So basically, we get under root 5 above, and this under root 5 multiplied by 5 would give us positive 5. And that's it. Basic. So B, 3 upon under root 2, multiplied by again under root 2 divided by under root 2, because we rationalize it. So 3 under root 2 divided by 2. Okay, so the thing is, now I'll kind of speed up these questions, not by 2x. I mean, I'll be going through my normal speed, but I'll be a little bit faster because the thing is, again, if you have seen the introductory lecture, I mean, do watch every one of my introductory lectures. I try my best to clarify each and every concept that is going to come in that exercise. So if you watch that, I mean, the whole exercise will be peanuts for you. Okay. So please do mind watching that. So it's part C again, 9 upon under root 3. What we do, we have to rationalize it. So multiplied by under root 3 divided by under root 3. We get 9 under root 3 divided by what? 3. Okay, so this can be further simplified. 3 1 is 3, 3 3 is 9. This would give us 3 under root 3 as the answer. Okay, proceeding on to question number 1, part D. For part D, we have, what do we have? Under root 2 divided by under root 6. So basically, we are going to simply multiply under root 6 divided by under root 6 first of all. So under root 6 2s are divided by under root 6 multiplied by 6 is equal to 6. Under root 12 divided by 6. Now, the thing is, most of you should right now know that we simplify the answer as much as possible. So when we are going to do that, we are going to check if we have the factors of 12. So 2 6 are 12, 2 3 are 6, and 3 1 is 3. So if we were to open this up, we would get under root 2 multiplied by 2 multiplied by 3 divided by 6. We get a pair of 2 here, so we make out 2 under root 3 divided by 6. Now simplify this, 2 under 2, 2 3 is 6. So under root 3 divided by 3 is your answer for this part. Now the thing is, again, I would like to emphasize the value of simplifying your answer as much as possible, and as that could make you gain marks or potentially even lose marks. Okay, for part E, we have 4 upon under root 5. So again, we multiply this by under root 5, divide by under root 5, basic things. We have been doing this throughout the exercises. We get 4 under root 5 divided by what? 5. And that's the most basic answer you could get. So F is 12 divided by under root 3. And 12 divided by under root 3, that would give us multiplied by under root 3 divided by under root 3. So basically, we got 12 under root 3 divided by 3. Again, simplify this up. 3 ones are 3, 4 is 12, and that's equals to 4 under root 3. And that's the most basic answer you could get. I mean, yeah, I might be getting a little bit fast here, but you know, these are my instincts. I'll try my best to stay as slow as possible. So 4 upon under root 12. Um, Again, the thing is, what we're going to do simply is multiply and divide by root 12. What you could do is basically, in fact, it's better to multiply and divide by root 12. You could also, I mean, that would not be the wrong technique if you simplify under root 12 to what was under root 12 equals to 2 under root 3. So if you are 2 under root 3 and multiply and divide by 2 under root 3, that would also be the correct thing. But I prefer to keep things as simple as possible and then simplify it in the last part. So it's up to your preference, whatever you want. So 4 under root 12 divided by what? 12. And again, we know from the previous parts that under root 12 is equals to 2 under root 3 because we have found out the factors. 12, 2, 6 are 12, 2, 3 is 6, 3, 1 is 3. Okay, so we get 4 under root 12, 2 multiplied by 2 multiplied by 3 divided by 12. So again, we get a pair of 2 out here. So 4 multiplied by 2 under root 3 divided by 12. And that would give you 8 under root 3 divided by 12. Simplify this. For 2 is 8, for 3 is 12. And that would be 2 upon 2 under root 3 over 3 would be your answer for part G. And the reason why I've been doing this, I mean, I tried to explain each and every question as well as possible, is because I know by a fact that most of you come here because you want to solve your specific queries. You do not watch the whole lectures, and yeah, it kind of hurts me. Um, it takes a lot of effort doing these lectures, so please do show your support. But the thing is, yeah, I try to, you repeat every concept I've told you, so that it could be easier for you if you are, looking at this lecture for a specific question, so that each and every question should be clear. So basically, that was emotional. Let's continue. For part E. No, sorry. What are we on? Not on part E. We are on part I. 3 upon under root 8. So again, multiply this by under root 8, divide by under root 8. This is going to give us 3 under root 8 divided by 8. So what is under root 8 equals to 2 to the 4 to 1, 4, 2 to the 2 to the 4 to 1 the 2. Okay, so this is equals to 2 cubes. So 3 under root what? 2 multiplied by 2 multiplied by 2. This is a under root, which means it is raised to the power what? 1 over 2. So we have to make a pair of 2. So 3 multiplied by 2 under root 2 divided by 8 would be equals to, our answer 2 ones are 2, 2 fours are 8. So 3 under root 2 upon 4 would be our final answer for part I. Okay, proceeding on to part J. Under root 2 divided by under root 32. Again, they're both not able to be simplified, so we are going to multiply and divide by under root 32. So under root 32, under root 32 here. So we get what? Under root 32 multiplied by 2. What's 32 multiplied by 2? 64. Under root 64 divided by 32. So under root 64 can be further simplified. And how can that be simplified? Now think about it. And you should use your mind to find out that 8 squared is equal to 64. So under root 64 is equal to 8. And that's again no big deal. That's your general knowledge. And if you don't know that, please do increase your mental maths. So that would be helpful. So 8 divided by 32 would give us 8 ones are 8, 8 fours are 32. 1 over 4 would be our answer for part J. That's our first answer in points, something like that. No, not the first answer in points, but the first answer in which we have a rational value to denote. So part J, and then we go on to part K. Under root 3 divided by under root 15 multiplied by under root 15 divided by under root 15. Yeah, I think you might see that activate windows thing. So I'll try to move it to the next page. But before I do, let me just simplify this. Under root 15 multiplied by 3 is, I guess, 75. Sorry, 45. Oh, my math's going off. So under root 45 is divided by 15. If I were to go down, I might have some space here. Let me just make a partition here. Here we go. Okay, we were proceeding on with part K. So we have continued. So we basically what we are going to do is under root 45. Okay, first of all, we are going to simplify under root 45. So under root 45 is 5 nines are 45, 6 threes are 9, 3 ones are 3. So again, we have a pair of 3, so that would simplify to 3 under root 5. Okay, so 3 under root 5 divided by 15. That would simplify to 3 ones are 3, 3 5 is 15. That would be under root 5 divided by 5. And that's it for part K. For part L, we have, let me just go up a bit. For part L, we have under root 12 divided by under root 156. Under root 12 divided by under root 156. Now, basically, we are going to multiply and divide this by 156. So under root 156 divided by under root 156. Here we go. We would get under root, what is 156 multiplied by 12? 156 multiplied by 12, 1872, and that's where things get bigger. Divided by 156. Now what I'm going to do is find my, use the highlighter. What I'm going to use is find the prime factors for 1872. So basically, this is going to be a long one. 1872. Simplify this. 2 9s are 18, and then we get this as 9 3s, and we get 6. Yep. So 936. This is divided by 2. Then we again divide by 2. 936 divided by 2. 4s are 8. 2 3s is 6. And no, I'm sorry. 6 are 12. 2 3 is 6. So 8. So 468. Then we go on. We get 2 divided by 2. 3 4 234. Then we get 2 1s, 2 1s, and then 2 7s are 14. Okay, so this is 7 8 9. So this is divisible by 3. So 3 3 is a 9 10 11 27. 3 9s are 27. 3 1s are 3. 3 3s are 9. Then 13 is a prime factor. Yes, 13 is a prime factor. So we are going to leave it as it is. 13 divided by 13. Then what we're going to do is find what this 1872 simplifies to. 2 multiplied by 2 multiplied by 2 multiplied by 2. How many 2's? 1, 2, 3, 4. 4 2's. And then 2 3's. 2 multiplied by 3 multiplied by 3 multiplied by 13 divided by 156. Now we get 1 pair, 2 pairs of 2, and 1 pairs of 3. So 2 2's are 4, 4 3's are 12. 12 under root 13 divided by 156. So what is 12 divided by 136? Let me check that out. 136. Sorry, not 136, 156. We would get 1 under root 13 divided by 13. And that's your final answer for part L. Okay. Um, Let me just make a partition here. Let us go on part M. What is part M? Let me just see it for a second. In fact, if you could give me 1 second, I could just find this out right here. Give me 1 second, please. For part 2, 3.5. 3.5, 3.5, 3.5. Here we go. 3.5 part M, if I'm not wrong. So part M, we have 5 divided by 2 under root 2. So again, multiply and divide by 2 under root 2. We would get 5 2s are 10 under root 2 divided by 4 2s are 8. So simplify this. 2 4s are 8, 2 5s are 10, and this is 5 under root 2 divided by 4. And that's our answer for part N. 5 under root 2 divided by 4. Proceeding on to part N, which is 7 divided by 2 under root 3. So we basically multiply and divide by 2 under root 3 again. The 7 2s is 14 under root 3 divided by 2 2s are 4 and 4 multiplied by 3 is 4 3s are 12. So 12. So 2 6 are 12, 2 7s are 14. That is equals to 7 under root 3 divided by 6. That is it for part N. For part O, we have, wait a second. For part O, we have what? 1 plus under root 5 divided by under root 5. Basically, what we do here is multiply and divide by under root 5. So what is under root 5 multiplied by 1 is under root 5, and what is under root 5 multiplied by under root 5? It's 5 divided by 5. And that's the most basic answer we could get. That's it. This is the answer for part O. And then proceeding on to part P. Part P, we have under root 3 minus 1 divided by under root 3. Again, multiply and divide by under root 3. So again, this is in brackets, so we multiply this by both of these values. So under root 3 multiplied by under root 3 is 3, and under root 3 multiplied by negative 1 is negative under root 3. Divided by under root 3 multiplied by 3 is 3. And yeah, that's the most basic answer we could get. That is it for part B. These are very simple questions, straightforward. Just know your concept and you'll find it really easy to solve them out. 3 minus under root 2 divided by under root 2. Again, the same thing, multiply and divide by under root 2 to rationalize the denominator. So again, 3 multiplied by under root 2, this is given as 3 under root 2. Negative under root 2 multiplied by under root 2 would give us negative 2. Divided by 2. And yeah, that's the simplest one. Okay. We go up here and let me just erase this up. We just raise this up. I mean, this is getting a bit messy. Okay. So this is Q. Last part, which is R, we would get 14 minus under root 7 divided by under root 7. So basically what we're going to do is again rationalize the denominator, multiply and divide by the same value. You would get under root 7 multiplied by 14, 14 under root 7, minus under root 7 multiplied by under root 7 is 7, divided by 7. So let me just check this up. I think this is not the simplest form. Okay. So basically what we do is now take the common out in. And it's been a long time before we have taken a common. But yeah, 14 is divisible by 7, and 7 is divisible by 7. So 7 has the common. 7 twos are 14, 2 under root 7. Yeah, 2 under root 7. Um, minus, in fact, sorry, 2 under root 7 minus 7 ones are 7 divided by 7. Now, basically, if you multiply these two values, you would get up this answer. So, we are doing our common factor correctly. Then this 7 cancels down by this 7, and the simplest answer you would get is 2 under root 7 minus 1. And that's your answer for part R, question number 1. That's it. Proceeding on to question number 2. Okay, in question number 2, it's again the same concept we discussed in the introductory lecture, and that's about conjugate surds. So basically, we have to rationalize the denominator and simplify it. And as we can see, we have an equation instead of a single surd term. So what we are going to do is rationalize this with the help of what? Conjugate surds. So question number 2, part A. So we are again 1 divided by 1 plus under root 2. We multiply this by 1 minus under root 2, which is the conjugate surd, as we have discussed before. Divide by 1 minus under root 2. So basically, the thing is, when again, I'm just repeating this concept that when we see 1 minus under root 2 divided by 1 minus under root 2, it's basically equals to 1. So we are multiplying by 1 in simple terms here. Okay, so 1 multiplied by 1 minus under root 2 is 1 minus under root 2, obviously, divided by so 1 plus under root 2 and 1 minus under root 2. So this is the quadratic formula a plus b multiplied by a minus b. And that would be equals to what? A squared minus b squared. So this is a basic example of what we're going to do. So basically, again, a squared is 1 squared minus b squared, what is under root 2 whole squared? It's equals to 2. So now let's just simplify this. 1 minus under root 2 divided by 1 minus 2 is equals to negative 1. Instead, what I would do is negative multiplied by 1 minus under root 2 divided by 1. And basically, why I haven't written negative 1 here is because I've taken this negative 1 and put it out in the common factor. So basically, this negative 1 goes up and multiplies with the numerator to make this independent of the negative sign. So we have got under root 2 minus 1 is equals to our answer for part A. Before I continue, just give me a second. For part B. Now for part B, we have 1 divided by 3 plus under root 5. 3 plus under root. Again, the same conjugate surd concept multiplied by 3 minus under root 5 divided by 3 minus under root 5. Again, if you do not understand it and if you're coming for a specific question, please do watch the introduction of this lecture and all your concepts will be clear. Proceeding forward. So again, 3 minus under root 5 multiplied by 1 is equals to 3 minus under root 5 again. But again, this is a plus b, a minus b. So a plus b, a minus b, and a plus b. So this is going to be equals to a squared minus b squared. So 3 squared minus under root 5 whole squared. So that is going to give us 3 minus under root 5 divided by 3 is 9 minus 5. And what is 9 minus 5? It's 4. 3 minus under root 5 divided by 4. 3 minus under root 5 divided by 4 is equals to your answer for part B. Simple. For part C, we have 1 divided by 3 plus under root 7. Again, there's conjugates here. Use them. 3 minus under root 7 divided by 3 minus under root 7. We get 3 minus under root 7 divided by a plus b. A minus b is going to be a squared minus b squared. So this is going to be 3 minus under root 7 divided by what's 3 squared? It's 9. And what's under root 7 squared? It's 7. So 9 minus 7 is equals to 2. So 3 minus under root 7 divided by 2 is your final answer for this part. Okay, proceeding on to part D. 4 divided by 3 minus under root 5. Again, multiply by 3 plus under root 5 because it's the conjugate third of this term. Divide by 3 plus under root 5. So what is 4 multiplied by 3 plus under root 5? 4 3s is 12 plus 4 under root 5 divided by, again, a plus b, a minus b, a squared. What is 3 squared? It's 9. And what is negative 5 squared? It's equals to, negative under root 5 squared. It's equals to positive 5. But right now it's going to be written as negative 5 because it's a squared minus b squared. So 9 minus 5, and we get that as 12 plus 4 under root 5 divided by, what is 9 minus 5? It's equals to 4. In fact, yeah, that's equals to 4. Now what we are going to do is we are going to take out the common. So 4 3s is 12. What is the common? 3 plus 1 under root 5 divided by 4. Cancel this down. We get our answer equals 3 plus under root 5. And that's it. This is it for part D. 3 plus under root 5. For part E, we have 5 divided by 2 plus under root 5. Again, what is the conjugate, sir, of 2 plus under root 5? We say it's equal to 2 minus under root 5. So 2 minus under root 5 divided by 2 minus under root 5. 5 twos is 10. 5 under root 5. That comes here. And again, a squared minus b squared for the conjugate third terms, a plus b, a minus b. So a squared, what is 2 squared? Is equals to 4. And what is under root 5 squared? It's equals to 5. So 4 minus 5. So 10 minus 5 under root 5 would be our final answer. In fact, 10, 5 under root 5 minus 10 would be our final answer for this one. And why is that? It's because it has 4 minus 5, which gives out what? Negative 1. And when we have negative 1, we multiply the upper numerator by negative to get rid of this negative sign and make it a positive. So that's what we did. And 5 under root 5 minus 10 is your answer for part E. For part F, we have again the similar thing, under root 7 divided by 2 minus under root 7. What is the conjugate set of 2 minus under root 7? It's 2 plus under root 7. So multiply it by 2 plus under root 7 divided by 2 plus under root 7. So what is under root 7 multiplied by 2? It's 2 under root 7 plus what is under root 7 multiplied by under root 7? It's 7 divided by, again, a plus b, a minus b. What is a squared? Meaning 2 squared is equals to 4. What is my under root 7 squared? It's equals to 7 itself. So we have got 2 under root 7 plus 7 divided by 4 is 4 minus 7, it's 3. So 2 under root 7 plus 7 divided by 3 would be our answer. In fact, it would be divided by negative 3. However, it's in the denominator, so we need to simplify it. So we'll remove this negative sign from the denominator and multiply the numerator by negative. So we would get something like, in fact, I would just like to solve this up in here. So if we multiply the numerator by negative, we get, wait a second. Okay. So we would get what? 200, negative 2 under root 7 minus 7 divided by 3. And that's your simple answer. That's for part F. For part G, we have 2 divided by 2 minus under root 3. 2 divided by 2 minus under root 3. Again, multiply by the conjugate surd, which is 2 plus under root 3, and divide by the conjugate surd, which is 2 plus under root 3. So we would get what? 2 multiplied by 2 is 4 plus 2 under root 3 here divided by what is a squared, 4 minus under root 3 squared is 3. So the final answer we get is 4 plus 2 under root 3 because 4 minus 3 is equals to 1. So simple. 4 plus 2 under root 3 is your final answer. For part H, we have 5 divided by 2 under root 3 minus 3 multiplied by 2 under root 3 minus plus 3, sorry, divided by 2 under root 3 plus 3. Again, the same thing is repeated here. What is 5 twos are 10 under root 3. And what is 5 threes are? Wait, here and then here. So what is 5 threes are? It's 15 plus 15 divided by what is a squared. So 2 under root 3 whole squared would be 4 multiplied by 3. I hope you know that until now. Plus, sorry, minus b squared, which is 9. So here we go. Simplify this 10 under root 3 plus 15 divided by 4 threes is 12. What is 12 minus 9? It's equals to 3. 12 minus 9 is equals to 3. So 10 under root 3 plus 15 divided by 3 would be our final answer for part H. And that's it. For part I, we have 1 divided by 2 under root 3 minus under root 2. Now, it may seem a little bit harder, but trust me, it's not. It's the same thing repeated again and again. They've just changed the type of question, I would say. They've added 2 surds instead of 1. That's only it. So what would be the conjugate surd for this one? 2 under root 3 plus under root 2 divided by 2 under root 3 plus under root 2. Okay, so we have got 2 under root 3 plus under root 2 in the numerator, and in the denominator, we have got a squared. 2 under root 3 squared is 2 twos is 4, and under root 3 squared is obviously equals to 3. So we have got 12 instead of 4 multiplied by 3. I would prefer to write 12. 12 minus what is under root 2 whole squared? It's 2. So 2 under root 3 plus under root 2 divided by 10 would be your final answer for part I. For part J, what I would do is I would go a little bit down this page. Delay, make a partition right here. I don't know why that didn't work. Now for part J. Let me just first copy it down. Part J is 8 divided by under root 7 minus under root 5. So basically, if I were to go down like that, and then just solve my question, J continued. Simple as that. Now, what we are going to do is, again, what is the conjugate of sir of under root 7 minus under root 5? Again, it's simply under root 7 plus under root 5, and then we divide it again by under root 7 plus under root 5. So we would get 8 under root 7 plus 8 under root 5, and then divided by what is a plus b minus b. So again, this under root 7 squared is 7. That's simple. Under root 5 squared is 5. So 7 minus 5. So that would give us 8 under root 7 plus 8 under root 5 divided by what is 7 minus 5? It's 2. So simplify this. 2 ones are 2, 2 fours are 8, and 2 fours are 8. So we would get simply 4 under root 7 plus 4 under root 5. And that's your answer for part what? Which part? For part J. For part J of question number 2. Okay. That's it. That's it for question number 2. We solved it up here. Proceeding on to question number 3. Okay. So for question number 3, before I proceed, wait a second. But question number 3, part A. So this tells us 2 minus under root 3 divided by 2 plus under root 3. Now the thing is, again, this is a conjugate surd. They are quite similar, the upper and below value, they're quite similar, but we won't do anything to them because it doesn't make sense right now. So basically, we just multiply this conjugate side, which is what? 2 minus under root 3 divided by 2 minus under root 3. Now, there are two quadratic identities we can use here. First is a minus b whole squared, because 2 minus 3 multiplied by 2 minus under root 3 would be again the same thing, and this would be also equals to 2 minus under root 3 whole squared. So we could use the quadratic identity a minus b whole squared is equals to a squared minus 2ab plus b squared. So that's what we are going to do. So what is a squared? It's 2 squared, which is equals to 4. Minus 2 multiplied by a, which is 2, multiplied by b, which is under root 3, plus b squared. What is under root 3 squared? It's equals to 3. Divided by, now what is a plus b? A minus b is equals to a squared minus b squared. So what is a squared? It's equals to 4. What is under root 3 squared? It's equals to 3. Simplify this. 4 plus 3 is 7 minus 4 under root 3 divided by 1. So nothing here. So 7 minus 4 under root 3 would be your answer for part A. For part B, we have 1 plus under root 2 divided by 3 minus under root. Now again, the same thing repeated, multiplied by the conjugate side, which is 3 plus under root 2, and divided by the conjugate side, which is 3 plus under root 2. Now, I'm going to use the FOIL method to multiply the upper values. In fact, not the FOIL method. It's two of them. Yeah, so FOIL method here, first and first. So 3. And then outer and outer value plus under root 2. Inner and inner value multiplied plus 3 under root 2. And the last value of both of them under root 2 multiplied by under root 2 is equals to 2. Divided by a squared minus b squared, which is a squared, it's 9 minus under root 2 squared equals to 2. So we simplify this. What is 5 plus 4 under root 2 divided by what's 9 minus 2 is equals to 7. And that's your answer for question number 3, part B. Proceeding on to part C, we have under root 2 plus 1 divided by 2 under root 2 minus 1. Again, multiply it by under root the conjugate surd. And what is the conjugate surd? We have discussed 2 under root 2 plus 1 divided by 2 under root 2 plus 1. Okay. So again, the upper value is the same. No, it's not the same. Sorry, my bad. Now I'm going to use my FOIL method here. First value multiplied by the first value is equals to 2 multiplied by under root 2 multiplied by under root 2, which would be equals to 2. Plus, so outer and outer values plus under root 2, inner values plus 2 under root 2, and the last value for both of them is just plus 1. Divided by what is a squared? 2 under root 2 whole squared. So 2 squared would be 4 and under root 2 squared would be 2. So 4 multiplied by 2 minus 1. So this would be equals to what's 2 to the 4 plus 1, 5 plus 3 under root 2, 3 under root 2 divided by 4 to the 8 minus 1, which is 7. So that's your answer for 5 plus 3 under root 7, 3 under root 2 divided by 7. That's your answer. For part D, we have under root 7 minus under root 2 divided by under root 7 plus under root 2. Again, we have the conjugate surds in division. So that means we are going to use two quadratic identities. Again, that's a shortcut. If you have two conjugate surds in the in division, you could just simply say, I am going to use two quadratic identities, because basically what we are going to do is find the conjugate surd of the denominator and multiply it by the numerator and the denominator, both of them. So under root 7 minus under root 2 divided by under root 7 minus under root 2. So again, as you can see, this one is a minus b whole squared because they're multiplying by each other. So I'm going to simply use the quadratic identity. What is a squared? It's equals to 7 because under root 7 squared is 7. What is minus 2 multiplied by a, which is under root 7, multiplied by b, which is under root 2, plus b squared. And what is b squared under root 2 squared is 2 divided by a plus b, a minus b is a squared, which is 7, minus what is under root 2 squared, it's equals to 2. So that would give us the answer 7 plus 2, 9, minus 7 2 is 14. So minus 2 under root 14. I guess this can be simplified. 7 2 is no, this can be simplified. So this is 7 minus 2 is 5. So 9 minus 2 under root 14 divided by 5 is your final answer for part D. And that's it for part D. For part, oops, that's a little bit off. Okay. For part E, we have under root 5 plus 1 divided by 3 minus under root 5 multiplied by 3 plus under root 5 divided by 3 plus under root 5, because that's the conjugate surd. Now, the next step, what we're going to do is simply multiply these two by the FOIL method. So first value multiplied by the first value, this is equals to 3 under root 5. Outer value multiplied by the outer value, which is equals to plus under root 5 multiplied by under root 5 would be equals to 5. Inner values is equals to plus 3, and the last value is equals to plus under root 5 divided by a plus b, a minus b is equals to a squared, which is 9, minus under root 5 squared, which is 5. So that's going to give us equals to 3 under root 5 plus under root 5 is equals to 4 under root 5 plus 5 plus 3 is what? 5 plus 3 is 8 divided by 9 minus 5, which is equals to 4. So 4 under root 5 plus 8. So this can be further simplified. 1's are 4, 4 1's are 4, and 4 2's are 8. So we can say 2 plus under root 5 would be our final answer for part E. 2 plus under root 5. For part F, we have something like under root 17 minus under root 11 divided by under root 17 plus under root 11. Again, we have conjugate surds in division, so we already know we are going to use two trigonometric identities. Sorry, not trigonometric identities, quadratic identities. Multiplied by under root 17 minus under root 11 divided by under root 17 minus under root 11. So what is a minus b whole squared is equals to under root 17 whole squared is 17 minus 2 multiplied by under root 17 multiplied by under root 11 plus under root 11 squared, which is 11, divided by a squared, what, 17 minus b squared, which is under root 11 squared, which is 11. So that would give us 17 plus 11 is what? 17 plus 11 is 28, and minus 2 under root what is 17 multiplied by 11. Let me just check this up. 17 multiplied by 11 is 187. So 2 under root 187 divided by 17 minus 11, which is equals to 6. So we are going to check if 187 in an under root would be further simplified or not. So we have 187 here. So 2, in fact, it's not divisible by 2. 8, 9, and 16. No, it is not. 7, 7, yeah. Oh, 7, yeah, so that's the thing. Under root 187 cannot be further simplified. Yes. So under root 187 would be the simplest value of the surd we could get. 28 minus 2 under root 187 divided by 6 would be your answer for part F. In fact, no, wait a second. We could simplify this further. Is equals to what can be taken out as a common 2. So 2 1's are 2, 2 4's are 8, minus under root 187 divided by 6. Now simplify this. 2 1's are 2, 2 3's are 6. So your final answer would go on to be something like, in fact, it would be 14 minus under root 187 divided by 3. Okay, so that's it for part F. Let me just proceed on to part G. Let's make a partition first. Okay, here we go. Let's copy down part what? Part G. Under root 3 minus under root 7 divided by under root 3 plus under root 7. So that's a simple question. Under root 3 minus under root 7 divided by under root 3 plus under root 7. Again, there are two conjugate surds in division. So we do know what to do. Before I do that, let me just label this as part G. Multiply this by under root 3 minus under root 7 and divide by under root 3 minus under root 7. So again, two quadratic identities. A minus b whole squared is a squared, or under root 3 squared is 3, minus 2 multiplied by under root 3 multiplied by under root 7, plus b squared, which is under root 7 squared, and that's 7, divided by a squared, 3, minus b squared, under root 7 squared is 7. This is 3 minus 7, and then we have got 3 minus. In fact, this is simple as that 7 plus 3 is what? Okay, I'm going to write it. 7 plus 3 is 10, minus 2 under root 7 threes is 21, divided by 3 minus 7. So that would be equals to negative 5. Sorry, negative 4. My bad. Negative 4. Negative 4. So this can be further simplified if we take out the common. So the common would be what? 2 as the common. 5 minus under root 21 divided by negative 4. Okay. So 2 ones are 2. 2s are 4. And we could say, because we have a negative sign in the denominator, to remove it, we multiply the numerator by negative. So we would get under root 21 minus 5 divided by 2 as our final answer. So that's it for question number 3, part G. For part H, we have, let's check it out. We've done part G, we have done part F, and now H. 23, under root 23 plus under root 37. Just copy that down. Under root 23 plus under root 37 divided by under root 37 under root 37 minus under root 23. And the thing is, this is kind of a, this is not kind of a, but this is a conjugate set. Now, many of you might not realize this because of the fact that it's kind of merged up. But yeah, if this is a positive sign on both sides, so I could also write this as under root 37 plus under root 23. And now if I would write the second term, I would realize that this is again a conjugate set in division form. So when that comes up, what we're going to do is multiply. And again, we know that two quadratic identities are going to be used. So under root 37 plus under root 23 multiplied by the numerator, and under root 37 plus under root 23 multiplied by the denominator. So basically what happens now is we use the FOIL method, simple as that. And not the FOIL method, my bad. We are going to use the quadratic identity a plus b whole squared. So what is a squared? It's under root 37 squared, and that's 37, plus 2 multiplied by a, which is under root 37, multiplied by b, which is under root 23, plus b squared, which is under root 23 squared, and that's equals to 23, divided by a squared minus b squared. Under root 37 squared is equals to under 37, and under root 23 squared is equals to 23. If I were to just make the partition and then continue, I would get something like 37 plus 23 would be 60. 60 plus 2 under root what is 37 multiplied by 23. 851 divided by what 37 minus 23 is 14. So 60 plus 2 under root 851 divided by 14. Before we go on forward, I would simplify 851 if it could be simplified. Let me just check it out. 851 here. Can we divide by something? 8, 5, 6, 8, 7, 1, 8, 2. No. So again, 851 is the most simplest thing we could get. So basically, how I configure it, it's not 851 is not further visible, or the sort of 851 cannot be further simplified. Is I realize that 851 cannot be divided by any prime factor. So simple as that. Any prime factor inside a set cannot be simplified further. So 60 plus 2 under root 851 divided by 14, we would get take out the common of 2. 2 as the common 30 plus under root 851 divided by 14. Now 2 ones are 2, 2 sevens are 14, and your final answer would be 30 plus under root 851 divided by 7. And that's it for question number 3. I hope it's clear. If there's any confusion in any type of question, feel free to ask it in the comment section. Question number 4. Question number 4, part A. Now we have to write this as a single fraction. And what they mean as a single fraction is, for example, we have 1 over 8 plus 1 over 2. What we basically do is we take out the LCM of 8 and 2, 2 and 8, 2 ones are 2, 2 fours are 8, 2 ones are 2, 2 twos are 4, 2 ones are 2, 2. And then we configure that 8 would be coming as the common. 2 fours are 8 multiplied by 4, so 1 plus 4 upon 8, and then 5 upon 8 would be the final answer. However, that's not as simple as it is in this question. So we are going to configure how to solve this up. I don't think it should take a lot of time. Just write it as a single fraction. So basically, when we write something as a single fraction, 1 divided by under root 3 plus 1 plus 1 divided by under root 3 minus 1. So basically what we are going to do is we multiply this section by this thing, and we multiply this by the second value. So that's basically what happens. So when we multiply 1 divided by under root 3 plus 1 multiplied by under root 3 minus 1. So again, we have to multiply it by the numerator also, because if we only multiply by the denominator, it's going to make a different value out of our equation. So we multiply on both sides. So under root 3 minus 1 multiplied by here also. Now plus, again, the same process here. 1 divided by under root 3 minus 1 multiplied by under root 3 plus 1. By the way, for those of, and before I do that, and then again, the numerator will be multiplied under root 3 plus 1. And that's a simple method. For example, again, I'm going to use that 1 over 8 plus 1 over 2 for your example. The thing is, 1 over 8 plus 1 over 2, we could also write this as 8 twos is 16. So we multiply it by 2 and this by 8, okay? Because we need 16 out of this. And we multiply both the denominator to get 16. And then we find out the value of the denominator, which would give that which would give that 16. So 8 twos is 16. So we multiply it by 2. So 2 and 2 eights is 16. So 1 multiplied by 8. So 2 plus 8. So 8, 9, 10 divided by 16. So 2 fives are 10. 2 fours are, 2 eights are 16. Again, we are getting the same answer as we did in the LCM method. So that's another method to find out the single fractions. Multiply both the denominators and find the value, and then multiply the denominator value by some value which will give you the original value. I know it may sound confusing, but here's an example. You could solve it like that. Okay, I hope that's clear. I tried my best to explain it, even though this is a really basic concept. So, under root 3 minus 1 is plus under root 3 plus 1 divided by what? So, under root 3 plus 1 multiplied by under root 3 minus 1. So, this is a plus b, a minus b. Simple as that, a squared minus b squared. In fact, what we are going to do is, let me just erase this up. It's basically, I'm sorry, I did a mistake here. So, under root 3 minus 1 plus under root 3 plus 1 divided by, now the denominator of both of them would be the same. So we can say that we can write it as a single fraction now. So under root 3 minus 1 plus under root 3 plus 1 divided by what is a squared plus um, a plus b, a minus b, it's equals to a squared, which is 3, minus b squared, which is 1. The thing is, basically what happens here is 1 under root 3, this goes on to simplify to under root 3 minus 1 divided by 3 minus 1 plus under root 3 plus 1 divided by 3 minus 1. So as the denominators are same, we can just write them as single fractions. That's what the basic rule of math tells us, if you don't know that. Okay, so under root 3 plus under root 3 is equal to 2 under root 3 minus 1 plus 1 cuts down. 3 minus 1 is divided by 2. So this cancels up. So under root 3 is your final answer for question number 4, part A. Okay. For part B, we have 2 divided by under root 7 plus under root 2 plus 1 divided by under root 7 minus under root 2. So again, the same thing, we multiply both the denominators. We get 2 divided by under root 7 plus under root 2 multiplied by under root 7 minus under root 2. And then again, we're multiplying the denominator, so we multiply the numerator with the same value. So under root 7 minus under root 2 plus 1 divided by under root 7 minus 2. So multiplied by under root 7 plus under root 2. Again, multiply the same value with the numerator, so under root 7 plus under root 2. Now, thing is, both of them are same, I mean the denominators, so we can write this as a single fraction. So under root 7 plus under root 2 multiplied by under root 7 minus under root 2, so that would use the quadratic identity a plus b multiplied by a minus b is equals to a squared minus b squared. So under root 7 whole squared is equals to 7 minus under root 2 whole squared is equals to 2. So 7 minus 2 in below, and on the above side we are going to get 2 under root 7 minus 2 under root 2, just simple multiplication and addition, plus under root 7 plus under root 2. So simplify this further, 2 under root 7 minus 2 under root 7, that cuts down, and under root 7 plus, wait a second, I think I made a mistake in the multiplication. So this would be minus 2 under root 2, sorry, plus under root 7 plus under root 2. Now we multiply this up, or simplify this up. 2 under root 7 plus under root 7 would give us 3 under root 7 plus, in fact, that would be negative under root 2 divided by, what is 7 minus 2? It's equals to 5. 3 under root 7 minus under root 2 divided by 5 is your final answer for part B. For part C, we have 2 divided by 4 minus under root 3 plus 1 divided by 4 plus under root 3. Basically, what we're going to do is, again, the same thing, multiply the denominators by each other. So 2 divided by 4 minus under root 3 multiplied by 4 plus under root 3. And again, we multiply the numerator with the same value as with the denominator. So 4 plus under root 3 plus 1 divided by 4 plus under root 3 multiplied by the other denominator value 4 minus under root 3. Then again multiply the numerator by the same value 4 minus under root 3. Simplify this, both of the denominators are same, so no big deal. So what we're going to do is use this as 2 4 2s is 8 plus 2 under root 3 plus 4 minus under root 3 divided by what is a plus b, a minus b is equals to a squared, 16 minus b squared under root 3 squared is equals to 3. So we are going to get 8 plus 4, which is 12. And what is 2 under root 3 minus under root 3? It's equals to plus under root 3 divided by 16 minus 3. This is equals to what? 13. 12 plus under root 3 divided by 13 is your answer for part C. Proceeding on to question number 5. Okay, so for question number 5, they've told us actually there's an area of a rectangle which is what? 8 plus under root 10 centimeters squared. They've told us one side of the rectangle is equal to under root 5 plus under root 2. It may be this side or it may be this side, whatever you want to. It's just for purpose of showing what it is. So they've told us find the length of the other side in the form a under root 5 plus b under root 2, where a and b are integers. Now we have known till now that whenever they tell us a form, it's mostly what? It's mostly the exact form we are going to write down it in. The thing is, right now, it's not one of our worries. The worries right now are how to find the other side. Assuming the other side is x. Okay. So what we're going to do is, what is the area of a rectangle? Area of rectangle. It's actually equals to length multiplied by breadth. So what we're going to do is, we know one side and we know the area, so we are going to input those values inside. So 8 plus under root 10 is equals to, one side is under root 5 plus under root 2, and the other is x. So we multiplied this by x. Now what we do is take this on the other side. So 8 plus under root 10 divided by under root 5 plus under root 2 is equals to x. Now we have discussed throughout this lecture the importance of rationalizing the denominator, because there should be no surd value in the denominator. So we are going to rationalize this. So, and how are we going to rationalize this? With the help of conjugate surds. Now, what is the conjugate surd of under root 5 minus plus under root 2? The conjugate surd would be under root 5 minus under root 2 divided by, again, in order to rationalize this, under root 5 minus under root 2. Now simplify this. I'm going to use the FOIL method for the above part. So the first value multiplied by the first value, 8 under root 5. Outer value multiplied by the outer value, minus 8 under root 2. Inner value multiplied by the inner value, that is going to give me positive under root 50. And the last value multiplied by the last value is equals to negative under root 20 divided by a squared minus b squared. So under root 5 squared is equals to 5 and under root 2 squared is equals to 2. Now simplify this further. So 8 under root 5. Right now, we can't make sense out of this answer. How can we bring it to the form a under root 5 plus b under root 2? Because we have under root 50 and under root 20. However, it is important to realize that we can simplify any cert further, not any cert, except if it is not a prime number. So under root 50 gives us 5 tens are 50, 5 twos are 10, and 2 ones are 2. And under root 20 gives us 2 tens are 20, 2 fives are 10, and 5 ones are 5. So we simplify this 8 under root 5 minus 8 under root 2 plus, instead of under root 50, we are going to write out under root of 5 multiplied by 5 multiplied by 2 plus, sorry, minus under root of 20, which is equal to 2 multiplied by 2 multiplied by 5, divided by, obviously, 3. So we further simplify this. This is equals to what? 8 under root 5 plus this. First of all, we simplify this. So a pair of 5 comes out, which leaves behind 8 under root 5 minus 8 under root 2 plus 5 under root 2 minus, again, a pair of 2. So minus 2 under root 5 divided by 3. Now this all is equals to x, which is the other side. Further simplify this, we get 8 under root 5 plus 5 under root, minus 2 under root 5. So what is 8 minus 2? Let's see, equals to 6 under root 5 plus, minus 8 under root 5, 8 under root 2 plus 5 under root 2. So this is going to give us 3 minus 3 under root 2 divided by 3. We're going to simplify this. 3 ones are 3, 3 twos are 6, and 3 ones are 3. So our answer would be 2 under root 5 minus under root 2 is our answer. 2 under root 5 minus under root 2 is our answer. I know this might be confusing by the fact that we do not have minus b under root 2, but a positive and negative change does come whenever you do these specific type of forms of questions. So that's basically it for question number 5. So 2 under root 5 minus under root 2 is your answer. It's not necessary to, make the addition or subtraction sign equal. The main necessity is to do what? Is to get the form a under root 5 plus b under root 2. And we have got that form 2 under root 5 minus 1 under root 2. So that's it for question number 5. Proceeding on to question number 6. Okay. Question number 6, we have a cuboid has a square base of length this. The volume of cuboid is this. Find the height of the cuboid. So basically, a cuboid, if I were to make this with a square base. So this is basically how a cuboid would look like. So what we have is the square base of length 2 plus under root 5. So this is a square base. So we are going to say that this is equal to 2 plus under root 5. And as this is a square base, so that means the other side is also equal to 2 plus under root 5. They have told us the volume of the cuboid is 16 plus 7 under root 5. So the whole volume of this thing is 16 plus 7 under root 5 centimeter cube. So basically, we now have to find what? We have to find the height of the cuboid, which is this. Second. So the height of the cuboid would be equals to this part, which we'll assume as right now x. So what is the volume? What is the formula for the volume of a cuboid? It's equals to length multiplied by breadth multiplied by height. Right now, we know all of these two values in which height is equals to x. So we have the volume of the cuboid 16 plus 7 under root 5 is equals to what is the length? It's equals to 2 plus under root 5. What is the breadth? It's equals to 2 plus under root 5 again, because these two values are actually equal. And why is that? Because that's a square base. So 2 plus under root 5 multiplied by 2 plus under root 5 multiplied by x. Now simplify this. 16 plus 7 under root 5 is equals to a plus b whole squared. So a squared, which is 4, plus 2 multiplied by 2 multiplied by under root 5, plus b squared, which is under root 5 squared, it's equals to 5. This whole is multiplied by x. Simplify this. 16 plus 7 under root 5 and is equals to 4 plus 5 is 9. So 4 plus 5 is 9. Oh, wait a second. 9 plus 2 to the is 4, 4 under root 5 multiplied by x. Now simplify this again, bring this into the division form to find out the value of x. 16 plus 7 under root 5 divided by 9 plus 4 under root 5 is equals to x. Now the thing is, again, a rule we have discussed, surds inside the denominator is unacceptable. So we are going to rationalize this. And what are we going to rationalize this with? We are going to rationalize it with conjugate surds. So 16 plus 7 under root 5 divided by 9 plus 4 under root 5 multiplied by 9 minus 4 under root 5 divided by 9 minus 4 under root 5. So now I'm going to multiply the above part with the FOIL method. So first multiplied by the first value, 16 multiplied by 9. And that's equals to, wait a second, 16 multiplied by 9 is 144. So 144 plus outer value multiplied by the outer value minus 16 multiplied by 4 would give us 64. So minus 64 under root 5. Inner value multiplied by the inner value is 9 multiplied by 7 under root 5, which would give us plus 63 under root 1. Last value multiplied by the last value is 7 multiplied by 4 is 28. So minus 28 multiplied by 5, because under root 5 multiplied by 5 is equals to or 5. So now I'm going to divide lower side and use the quadratic identity a plus b multiplied by a minus b is equals to a squared minus b squared. So what is 9 squared? It's equals to 81. And what is b squared? 4 squared is equals to 16 multiplied by under root 5 squared, which is 5. Simplify this. 144 minus 28 multiplied by 5. What is 28 multiplied by 5? 28 multiplied by 5 is equals to 140. So 144 minus 140 is equals to 4. Minus 64 under root 5 plus 63 under root 5 would give us minus 1 under root 5. So we are going to write it as minus under root 5 divided by 81. So what is 16 multiplied by 5? 16 multiplied by 5 is equals to 80. So what is 81 minus 80? It's equals to 1 itself. So 4 minus under root 5 is your answer for this part. I mean, there were some values which were big in this question, but the thing is they canceled out and gave us a simplistic answer. In fact, 4 minus under root 5 centimeter is your answer. And that's it for question number 6. Proceeding on to question number 7. A right circular cylinder has a volume of um 25 plus 14 under root 3 pi centimeter cube and base radius of this. Find the height. So thing is, I'll try to make a cylinder first of all. I hope so it works. Ow. Then this part. Think we made it. Let me just adjust this one. And I guess that's it. This is how a cylinder looks like. And that's about it. So basically, I think I get the for this one line bomb. Let me just fix this one very quick. Okay, that's okay. Okay. So now the thing is they've told us this there's a right cylinder which has a volume of 225 plus 14 under root 3 pi centimeter cube. Okay. They've told us the base radius is 2 plus under root 3. So the base radius is 2 plus under root 3 centimeter. Find the height. So basically we have to find the height, which is this part of the cylinder. We'll assume for now the height is what? Equals to x. So what is the volume of a cylinder? Volume of cylinder is equals to pi r squared h. So right now we know all of these values and we have assumed them all. So just input those values. What is the volume given in the question? 25 plus 14 under root 3. And we have a pi with that. Is equals to pi multiplied by what is r squared? We have the radius 2 plus under root 3 whole squared. And what is the height? We have assumed it to be x. The thing is, at both sides we are getting pi to be multiplied, so pi can be easily cancelled out because this pi would divide up here and that would cancel out the other pi. So right now we have 25 plus 14 under root 3. And if we were to take this 2 plus under root 3 on the other side, we would get divided by 2 plus under root 3 whole squared is equals to x. Now, before we do anything else, let's simplify this 25 plus 14 under root 3 divided by a squared, which is 2 squared 4, plus 2 multiplied by a multiplied by b plus b squared, which is under root 3 squared equals 3. Simplify this further, 25 plus 14 under root 3 divided by what is 4 plus 3? That's equals to 7. Wait a sec. That's equals to 7. And what is 2 twos of 4 under root 3? So again, one rule we have discussed till now, no surds in the denominator. So what we'll do to remove that surd, we'll rationalize this. And how will we rationalize this? We'll do this with the help of a conjugate surd. So we multiply this by 7 minus 4 under root 3 and divide this by 7 minus 4 under root 3. So again, essentially, we are multiplying by 1, which does not change the value. However, it allows us to remove the side from the denominator. So again, I'm going to use my FOIL method here. So first value multiplied by the first value. What is 25 multiplied by 7? That's equals to 175. Outer value multiplied by the outer value, which would give us minus 25 multiplied by 4 is 100. So minus 100 under root 3. Inner value multiplied by the inner value, 7 multiplied by 14. 7 multiplied by 14 is equals to what? 98. So this is going to give us plus 98 under root 3. The last value multiplied by the last value is going to give us 14 multiplied by 4, 56. So minus 56 under root 3 divided by, again, simplify this with the help of a quadratic identity, a plus b multiplied by a minus b. So a squared, 7 squared is equal to 49 minus 4 squared is 16 multiplied by under root 3 squared is equals to 3. Simplify this further, we would get 175 minus 100 plus 98. So minus 100 second plus 98. Sorry, not plus 98. And well, that's negative 2. And we subtract negative 56 further. So we are going to get negative 58. 175 minus 58 under root 3 divided by 49 minus, what is 16 multiplied by 3? 16 multiplied by 3 is 48. So 49 minus 48. So 49 minus 48 is equals to 1. So 175. This is question number 7. So 175 minus 58 under root 3 is equals to your answer to question number 7. Okay, for question number 8, what we're going to say is find the value of tangents. And now basically, it's really important to know again the trigonometric, what you could say, equations for this question. And the thing is, we know that tan x is equals to what? Opposite upon adjacent is equals to tan x. Okay, we already know that, and that's going to be applied in this question. So the thing is, that we know what's the value for tan x, and it's essential to remember that we have to give it in this form. That means our answer would be what? Exact. Okay, we have discussed in the previous parts that whenever they've given us a specific form for our questions, we term that as exact answers because we are not giving them in decimal places, or in simpler layman's term, we are not rounding them off. So that would be taken in effect. Also, remember that they have asked us for tan x, not for x. Okay. Okay, so do remember that because you have to give the value for tan x, not the tan x, nor we are not going to do tan inverse and that. That's the other step. They've restricted us to that. Okay, we are only supposed to find tan x. So just simply going on, we know that tan x is equals to what? Adjacent upon, opposite upon adjacent. So what is the opposite angle for this x? It's AB. So we are going to say 3 plus under root 2. And what's the adjacent line to this angle? It's BC. So what's the length of BC? Divided by 1 plus 2 under root 2. 1 plus 2 under root 2. Now, simple as that, just multiply with the conjugate surds we have discussed till now. So basically, we are going to multiply 1 minus 2 under root 2. Divided by 1 minus 2 under root 2. And I've seen many students making a mistake in this specific type of question. That what they do is just leave the answer to this. Okay, 3 plus 2 under root 2 divided by 1 plus 2 under root 2. That would be technically correct, but the thing is, it won't be correct at the same time. You lose marks for this because you have not rationalized the denominator. So it's really important to rationalize the denominator whenever you get a third value inside. So do keep that in mind. So we have 10x. Just use the FOIL method to multiply the above values. So first multiplied by the first value, so 10x is equals to 3 multiplied by last value minus 6 under root 2 inner value plus under root 2 and the last value minus 2 multiplied by under root 2 multiplied by under root 2 would be 2 multiplied by 2 divided by a plus b multiplied by a minus b. We know that that's a quadratic identity. So that means a plus b multiplied by a minus b is equal to a squared minus b squared. So we are going to get a squared minus b squared. What is b squared equals to? 2 squared is equals to 4 multiplied by what is under root 2 squared is equals to 2. Simplify this now. 3 minus 4 minus 6 plus under root 2. What's that equals? That equals negative 5 under root 2. So the 3 minus 5 under root 2 divided by 1 minus 8. Then we go on to further simplify this and we get 10x is equals to, what's 3 minus 4? It's equals to 1. In fact, it's equals to negative 1. Negative 1 minus 5 under root 2 divided by what is 1 minus 8 is equals to negative 7. So now what I'm going to do is take negative as a common out here. So we are going to get, in fact, that would be last. So we are going to get as negative as a common 1 plus 5 under root 2 divided by negative 7. I hope you understand this because we multiply negative here. So we get negative 1 minus 5 under root 2 and that would be the exact same value. So we are taking the common out of it. Now we cut down the negative signs from the denominator and the numerator and we get a positive value which is much more simpler. Tan x is equals to 1 plus 5 under root 2 divided by 7. And that's your answer for part A. Let me just highlight this up a bit. And here we go. This is it for part A, question number 8. I hope you understand it. Really simple, no big, no rocket science in here, to be honest. Just some concepts. Find the area of the triangle. Write your answer in this form. So the thing is, they've asked us for the area of this triangle. So we know what's the area of a triangle equals to area of triangle. Area of triangle is equals to 1 over 2 multiplied by base multiplied by height. That's the basic formula. We know both of them. We know the base and we know the height of this triangle. So what we're going to do, by the way, again, we put this into the exact form, a plus b under root 2 divided by c. So this is equals to 1 plus 5 under root 2 divided by 7, where a is equals to 1, b is equals to 5, and c is equals to 7. Just wanted to emphasize that. So 1 upon 2 base multiplied by height is your area of triangle. So what we're going to do here is we're going to say area is equal to, first write it in the base terms. We're going to find out how we're going to simplify it further later. First write what you're going to handle. So 1 over 2 multiplied by 3 plus under root 2 multiplied by 1 plus 2 under root. Okay. So I don't think this is going to be much of a hard thing because there's no rationalizing. Just multiply this area is equals to what's, again, I'm going to use my FOIL method here. So 3 multiplied by first value 3. Outer value multiplied by the outer value, which is equals to 3 to the 6 under root 2 plus 6 under root 2 inner value multiplied by the inner value plus under root 2. Again, the same as we did here, multiplied by the outer value multiplied by the outer value. So this is going to be equals to plus 2 under root 2 multiplied by 2. So this is 2 multiplied by 2 itself. So divided by what? 2, because it's multiplying by 1 over 2. Okay, for question number 9, we have been told to find cos theta itself. So as in the previous lecture, we decided what tan x would be. Here we are going to say that cos x is equals to what? What's cos x equals to? It's equals to adjacent upon hypotenuse. But the thing is, it's not going to be applicable in this question. And why is that? Because this is not a right angle triangle. And these trigonometric identities are only used for angles with 90 degrees in them. So the thing is, what we are going to do here to find the cos value out is we are going to use the cosine law. And let me just write this cosine law out for you. So cosine law, as we've discussed, I hope you know this by now. It's in trigonometry, however. But cosine law, it's O-level maths, so it's supposed to be basics. So if you do not know that, I think you might learn that in maths later on. But basically, cosine law is a squared. In fact, I'm going to write it in this way. So in as cosine law states, c squared is going to be equals to a squared plus b squared minus 2ab cos c. So basically what happens here is we simply find out a side, okay? We find out the side. This is for finding out any side if you want. May it be AB, may it be BC, may it be AC. However, we have these sides, what we do is we merge them up to find out the angle value. So cos C is basically the angle. So what we're going to do is say that cos C is equals to a squared plus b squared. If I would mumble that, minus c squared divided by 2ab. Okay. Just wait a second before I go forward. Yeah, so we are good here. Now the thing is, what we're going to do is just we have this formula for cos c, and we assume that this c is equals to cos theta. So cos theta is equals to a squared plus b squared. Sorry, I don't know why that squared did come. A squared plus b squared minus c squared divided by 2ab. So what we're going to do is simply just input this into the formula. So we know that where's my mark? So we are assuming that this is c, or you can say theta, whatever you want. So cos theta is equals to a squared. And now the thing is, it's really important to know what a, b, and c is. If I were to choose my marker here, use a more broader tip and choose this one. So A, B, and C is basically the angle's exact opposite. For example, if I classify this angle as A, the exact opposite side would be A. Okay. If you know what I'm talking about, it's a basic rule in maths. So the thing is, if I configure this angle as B, the exact opposite side of that angle would be B. And if I configure this theta as C, for example, the exact opposite side would be C. So that's basically how we put these things into. So that's how it basically is. So for your easiness, I'm going to do is label each of these. So I'm going to say if I were to take theta as C, obviously, I'm going to say the exact opposite side of that would be, that line would be called C. So this is the side C. If I would take this as A, the exact opposite side would be A. And if I would take this as B, the exact opposite side would be B. Okay, so once you understand this, it's going to be really easy for you to solve this question. So now, as we have everything labeled up, what we are going to say, and by the way, you can label anything that you want to anything. Okay, So just remember that. So question number 9. What you've told us, find the value of cos theta. So as we've discussed here, cos theta is equals to what? C. So a squared. What have we labeled as a squared? This is a. So this is a. 5 centimeter is a squared. 5 squared plus b squared. So where is angle B? This is angle B. So this side is B. So I don't know if you can see my cursor, but this is angle B. So the opposite side is B. So we are going to say 5 plus, what is B squared? This is 3 squared. What is a minus C squared? So this is angle C. And the opposite of that angle would be 2 plus under root 7. So 2 plus under root 7. I would prefer to write this in a bracket and square this up. Divided by 2ab. Again, what's 2 is simple, it's an integer. What is the value a? It's the exact opposite of the angle a. So that's 5. And what's b? It's the exact opposite of angle b, which is 3. So this is simple. What we're going to do is just simplify this further. Cos theta is going to give us 5 squared is equals to 25 plus 3 squared is equals to 9 minus, now this is a plus b whole squared. So what is the formula for that? We use the quadratic identity. So a plus b whole squared is equals to a squared. What's a squared? 2 squared plus 2 multiplied by a multiplied by b under root 7 plus b squared, which is under root 7 whole squared, divided by, simplify this, 5 3s is 15 and 15 multiplied by 2 is 30. So cos theta is equals to 25 plus 9. What is 25 plus 9? It's equals to 34. 34 minus, we're going to use simplify this, 2 squared is equals to 4. And what this is going to be equals to 4 under root 7 and plus 7 here, divided by again 30. So simplify this further, cos theta is going to be equals to 34 minus, now multiply this negative by every single value. Let it be 4, let it be 4 under root 7, and let it be 7. So just keep that in mind because this is a bracket here, so we multiply by each and every value. So minus 4 under root 7 minus 7 divided by 30. Simplify this further. Let me just do it for a second. So cos theta is equals to 34 minus 4 minus 7. So 34 minus 4 is equals to 30. 30 minus 7 is equals to 23. So 23 minus 4 under root 7 divided by 30 would be your final answer for question number 9. And that's it. This is basically how we solve these type of questions with the cosine law. I hope you know the cosine law by now. It's a part of O-level and IGCSE mathematics. So that's a compulsory subject. You should know that. Cosine law and sine law are basically a general knowledge you should know by now. Proceeding on to question number 10. Okay, for question number 10, what we are going to do is we are going to first of all read the question out thoroughly because it's kind of a confusing and a lengthy question, to be honest. So the blue circle has a radius of 2 units. They've not told us centimeter meters. They've just told us that it's 2 units. And this is green circle has a radius of 1 unit. So AB is a common tangent and all 3 circles touch each other. Now these 2 things are really important for us, okay? For AB is a common tangent. That means all of them are touching AB. And what is a tangent? First of all, it's important to realize that a tangent is anything which touches a circle or any other thing at only one point, okay? So each of these circle has a common tangent. Each of them are touching the tangent AB. That means they are standing on the same plane. They are on the same altitude. So we can say that all of them are standing in a straight line. Okay. The other thing they have told us in this sentence is that all 3 circles are touching each other. That means the blue circle is touching the orange circle and the green circle, and vice versa for each of these circles. So what we're going to say and it's just a shortcut. It's not necessary it will work every time, but it comes in most of the cases that whenever we have a question that means the touching of each of circles touching each other, that would mean we have to construct a triangle inside them. It's mostly how these question comes up. So just remember that as a tip. It may come in handy, useful. Okay, so what we second thing is we're going to represent this question in a more diagrammatic way. And how we're going to do is that we're going to label each and everything. So if we were to say that this is the radius of this blue circle, it's equals to 2 centimeter. The radius of the green circle is we're going to say equals to 1 unit or anything. I'm sorry, I said 2 centimeter, while it is not that case. By the way, I want to just check if it is coming straight up. Okay, I think it's okay. By the way, another thing to realize, and it's about making your questions more perfect, is that you have to go into the intricacies, you have to go in more depth. The thing is that the radius of this circle is equal to 2, and the diameter, remember I have said diameter not radius, of this circle is equal to 2 because 1 plus 1 is equal to 2. So we can say that the center point of the circle will be at the height of the circumference of the green circle. So it's really important to realize that one thing, and it's going to make your question much more understandable to you. So the second thing what we're going to do is we're going to connect the dots for each of these questions. By the way, let's assume for now that the radius for the orange circle, for orange, yeah, smallest, or we can say smallest circle. Smallest circle is equals to what? It's equals to r. Okay, let's assume it as r. So we have the radius of the smaller circle, which is r. And if I were to make this up here, I don't know if it would look good or something. This is equals to r. Okay, just a rough representation of what we are going to go through. Okay. So the second thing we are going to do is connect the dots for them. Now the thing is we need a triangle, we need to connect each of these values individually are of no use to us. So what we're going to do is connect each of them. Okay, so this is here, this comes here, and this comes here. Again, remember this is not a right angle triangle. It may look like one, but it is not actually. Okay, so the thing is, how do we configure each of these length of these sides? Okay, so the thing is, we already know that the radius of this blue circle is 2, and the radius for this orange circle is r. So there's no gap coming in this line. It's just passing through the orange circle and the blue circle. So we can say that this side is equals to 2. In fact, let me write it in this way so that it's more easier to. So this side is equal to 2r. And why is that? Because this 2 is the radius and this 2 is the radius of the smaller circle. So 2 plus r as it goes to the radius of each of these circles. Similarly, for this side, this is going through the radius of the smaller circle, which is r, and this would be added into the radius of the green circle. So this would be equals to r plus 1. So 1 plus r, we're going to write it down here. And for the third side, again, it's 2 connecting down to the green circle. So 2 of the blue circle plus the radius of the green circle is going to be 2 plus 1, and 2 plus 1 is equals to 3. We know that already. Okay, so that's equals to 3. Now proceeding further, we would get something like, now the thing is, how can we find our further values? For that, we're going to construct another line. And that's going to come from the center point from the blue circle down to the tangent AB. And when we need that, we do not need this whole line. We need the line which connects the R, basically. So if I were to find the distance from um, the center point all the way down to this intersection point, I would not say this is equal to 2. 2 is the value for the whole radius. This is equal to 2. But right now, I need this single value from the center point down to the intersection point. And what would that be? It would be 2 minus r. And why is that? Because this whole is equal to r, as we can see. This is the radius of the orange circle. So what we're going to say that this is equal to 2 minus r, and that's because we're going to erase this part. So that would be equal to 2 minus r. Similarly, for the line residing in this one, we're going to do the same straight line. We're going to connect this with the radius of the smaller circle. It's getting in this way for this. Okay. Now, if I were to erase this one, what would be the distance equals to? It would be equals to 1 minus r. And that's because from the radius of the circle, we are subtracting the radius of the smaller circle, as we can see here. So this would be 1 minus r. And now we have individual values for each and every one of these. Now let's label the unknown values for each of these two triangles. For triangle 1, this one. So we'll assume that this is equals to x and this side is equals to y. So these are two unknowns, x and y. And it may arise to you, why do we actually need these values? The thing is, if we were to find x, first let's find x and y, and then you'll get to know as we go through all the question. And that's the method I like to go through with. I mean, if we solve the question accordingly, then we'll get to know it much more easier. So question number 10. For the blue circle, it has a radius of 3 and okay. So first of all, for this question, what do we encounter the problem as? We need to find the value of x and y. So the thing is, for x and y, we already know they are right angle triangles. These two are right angle triangles because they're parallel to the tangent AB. So this is a right angle triangle. So we can easily say we are going to apply the hypotenuse rule in here. So how do we find the hypotenuse? What's the hypotenuse value actually? 2 plus r whole squared is equals to x squared plus 2 minus r whole squared. Okay, because this is the hypotenuse. Now we just simplify to find out the value of x. So 2 plus r squared minus 2 minus r squared is equals to x squared. Now simplify this to find out the value. Again, we are going to use our quadratic identities. A plus b whole squared is equals to a squared. What is 2 squared is equals to 4 plus 2 multiplied by a multiplied by b plus b squared, r squared, minus a squared, again 4 plus 2a, sorry, minus 2ab, minus 2 multiplied by a multiplied by b plus b squared is equal to x squared. Now simplify this. 4 plus 4r plus r squared minus 4 plus, again, why is that plus? It's because this negative is multiplying here. So plus 2, 4, 2 2s is 4. We're going to say this is 4r plus r squared is equals to x squared. Now simplify this further. 4 minus 4 cuts down, and 4r plus 4r squared. Oops, I'm really sorry. I found a mistake, and that's we are not going to say this is positive r squared. It's negative r squared here. I'm really sorry for that because this negative sign is multiplying here also. So this is negative r squared. So r squared and r squared cancel down. 4r plus 4r is equals to 8r, and that's equals to x squared. So x would be equals to under root 8r. If we were to simplify this, we would get under root 8 multiplied by under root r is equals to x. And what's under root 8 equals to? It's equals to 2 under root 2. We have been discussing this throughout the exercises because 8 is equals to 2 cube. and we simplify this to 2 under root 2. So multiplied by under root r, and that would give us x is equal to 2 under root 2r. Okay, now that we have found out the value of x, we are going to proceed on to find out the value of y. Simple as that. Again, y is again a right angle triangle. Sorry, this triangle is again a wide angle triangle. So if we were to make the hypotenuse equation for this, we would get 1 plus r whole squared is equals to 1 minus r whole squared plus y squared. Now simplify this to find out the value of y. Y squared is equals to 1 plus r squared minus 1 minus r squared. That's a whole squared, not 1 minus r squared. So y squared is equals to, again, we are going to use our quadratic identities here. A squared is equals to 1 squared plus 2 multiplied by a multiplied by b plus b squared minus a squared minus 2 multiplied by a multiplied by b plus, uh, in fact, yeah, plus b squared, which is r squared. Simplify this, y squared is equals to 1 plus 2r plus r squared minus 1, again minus 2r and minus r squared. Now simplify this, r squared and minus r squared are cancelled down. Negative 2r and 2r are cancelled down. Oh my god, I made a mistake again. I don't know why I'm making these mistakes. Uh, and this is plus 2r, not minus 2r, because this is negative multiplied by negative is positive. I highlighted it, but I still made it wrong. So this would cancel down. So we would get y squared is equals to 1 minus 1. We would get y squared is equals to 4r. We would get y is equals to under root 4r, which is further equals to under root 4 multiplied by under root r. And that would give us y is equals to under root 2r. Now that we have, in fact, sorry, not under root 2r, 2 under root r. I'm really sorry for that mistake. Now that we have done all of this, we need to know why have we found this x and y out. And the reason why we found out x and y is that, let me just go on to this. We know that this x and y are parallel to this, okay? Let me just first create a line like that. And that would connect this circumference down here, and we would get up here to this. Okay, so basically what's happening here, this, if I were to say this line is equal to x plus y, you won't say that I'm wrong. And that's because, well, these two lines are parallel to each other and they are the same. I mean, if you were to see this, this is making a kind of a rectangle, if I were to say that. So we can say that this side and this side are the same. Okay, so we can say x plus y is equals to this line. And the reason why I found out this x and y is because in this triangle, again, this is a right angle triangle. We do not know this x and y. We know this one. This length of this triangle is 1, and the length of this triangle is 3. And this is equals to x plus y, and we can find out the value of x plus y with the help of the hypotenuse method. I know this is a little bit confusing. You may ask that how do we come from this triangle to finding out this triangle to finding out this triangle and then using those two values to find out this triangle. And I mean, that's the beauty of being an AdMath students. I mean, you should use your brain. You should know the concepts that you are going to encounter. And that's basically it. So basically, we're going on. Let me just uh, get to this. So basically, it told us x and y. So if I were to write the equation for this here, I would say that this is a hypotenuse. What would be the hypotenuse, by the way? So this is the hypotenuse. So this would be the three side would be the hypotenuse. So we are going to say that 3 squared is equals to x plus y whole squared plus what? Plus 1 squared, as you can see. So if I were to simplify this now, plus 1 whole squared. Now, if I were to simplify this, I would get 9 is equals to x plus y whole squared plus 1. Okay, 9 minus 1 is equals to 8 is equals to, again, I'm going to replace the value of x and y. We have found out here x is equals to 2 under root 2r and y is equals to 2 under root r. So we have got x, so x, 2 under root 2r plus 2 under root r whole squared is equals to 8. I'm going to simplify this further. I'm going to use my quadratic identity here. So a squared, what is 2 under root 2 whole squared? So we are going to say 2 squared is equals to 4. Under root 2r will become 2r when squared up. Plus 2ab, 2 multiplied by 2 under root 2r multiplied by 2 under root r plus b squared, which is going to be 4r. Simplify this further. 8 is equals to 4 to the is 8r plus 2 to the 4, 4 to the 8. 8 under root 2r squared plus 4r. Simplify this further. 8 is equals to 8r plus 4r is 12r plus 8 uh, r under root 2. And the reason why I've written 8r is because this is r squared, and when r squared is in under root, it becomes R. Okay, we know this throughout the lecture. We have been discussing these type of questions. And if you are solving this type of challenge question, you should know these basic concepts. I mean, it's time to level up your mental math skills. I mean, the October, November, in fact, are really near the time I'm recording this lecture. But you should know how to do each and every type of question. So 8 is equals to r as the common 12 plus 8 under root 2. So further simplify this, 8 divided by 12 plus 8 under root 2 is equals to r. Now that we have found out the value of r, we should be happy. But the thing is, this is not going to be your answer, because when you do not rationalize your denominator, it's going to be wrong. And before we rationalize the denominator, I would like to simplify this question, because 4, if we take out 4 2s as 8 divided by, we take 4 as the common here, 3 is a 12 plus 2 under root 2. And this can be cancelled out. So 2 divided by 3 plus 2 under root 2 is equals to r. Now, if you want to rationalize this denominator, we would get 2 divided by 3 plus 2 under root 2 multiplied by 3 minus 2 under root 2. And why is that? Because we multiply with the conjugate cell in order to rationalize the denominator. Divided by 3 minus 2 under root 2, and that's essentially equals to 1. This part is essentially equals to 1. That's just a reminder. We have discussed this throughout the lecture. So if we were to simplify this, we would get r is equals to 3 to the 6 minus 4 under root 2 divided by, again, a plus b, a minus b is equals to a squared minus b squared. So 3 squared is equals to 9 minus 2 squared is equals to 4, and under root 2 squared is equals to 8. So we have got 6 minus 4 under root 2 divided by 9 minus 8 is equals to 1, and r is equals to 6 minus 4 under root 2 is our answer for the radius of the smaller circle. And that's it for question number 10, which is the challenge question of this exercise. And this ends the lecture, and obviously exercise 3.5 also. And that's it for today, and meet you in the next lecture. Thank you.